All right, let's do exam 3. So we're going to solve the triangle for number 1 and then find the area. And then we'll do the same for number 3. 3 will have 2 triangles. 4 is a law of cosine, so it'll have 1 triangle. And you can also prove these things, explain why there's 1, 2, or none. Once you find it, you do the area. If there was no triangle, then you would not be able to find area. So if that happened, you just say no area or undefined, right? So first 4, 5 is hopefully not too bad. Okay, so number 1. Solve the triangle, and they gave us A equal to 20. We don't have B. C is equal to 25. Little a is missing. Little b is missing. Little c is 80.5. So I have an opposite and an angle and a side opposite to that angle. So I can do law of sines, and I'll do it on this one to find little a. So what I'm going to do is set a over sine a equal to the piece that is known, c over sine c. Solve for a, that'll get us to here. So c sine a over sine c, right? So this will be 80.5 sine 20 over sine 25. And then it's calculator time. That should be, we'll round to 3 decimal places, 65.148. Now do the same thing for little b. Although we need this angle, but if you subtract from 180, right, we can get capital B, no problem. So let's do that next. Should have done that first, but B will equal 180 minus A and C. So 180 minus 20 degrees minus 25 degrees. Okay, that will be 135. I'll put it over here to save space. Okay, so now we have B. We have A, 65.148. Okay, so make a little note for where I started each step here. I don't confuse myself or you. So now let's do B over sine B equal to what was given, C over sine C. Solve for B. That would be C sine B over sine C. Okay. So plug everything in. That will be 80.5 sine of 25 Oops, no, 135. Over sine of 25. So little b will be 134.689. Okay. So we found the three missing sides. Capital B was not given. Lowercase b was not given. And lowercase a was not given. There we go. 2. Find the area. With problem 1. So all you need is this 3 sides to do so. So you gotta find these first, right? So area using Hero's formula is equal to S times S minus A times S minus B times S minus C, where S is equal to 1/2 times A plus B plus C. Okay. So our A is 65 point. I'm gonna just round to a single decimal. Well, you know what? That's fine. Right. It's okay. A is equal to 65.148. B is 134.689. C is 80.5. Since this one has a single decimal point, I'm going to round to 1 for this part. Okay. S is equal to 1/2 times 65.1 plus 134.7 plus 80.5. 65.1 plus 134.7 plus 80.5 divided by 2. There's S. So the area A is equal to the square root of 140.15 times 140.15 minus A 140. It's not on the screen, darn it. 140.15 minus B 140.15 minus C. This will be roughly, I didn't give anyone any issues for rounding or being off by a little bit. As long as you plug this in correctly, you should be good. Should be around here, 1854.172. Anyway, for number 3, I'm gonna actually, I didn't explain why there's only one triangle here. We'll do so on the next one, and the 3rd and 4th. But you should always check. Oh, I forgot to mention, on number 1, you were given 2 angles, so you're only gonna have one triangle. On number 3, you only give me 1 angle. So you're going to have to check for two triangles. Number 4 is a law of cosine question. So you don't have to worry about two triangles. Okay. So here you for sure have to check and show. So either explain that or prove it using the idea that a triangle must be less than 180, the sum of the angles. So let's find capital B first. Okay. So here we go. Sine B over B is equal to sine A over A. To save some space, you solve for sine B and then use the, let me show the step. Multiply both sides by B. Then do sine inverse of both sides. So sine inverse of B sine A over A. So B is equal to 248.6 sine of 43.1 over 186.2. Sorry, I got distracted. Let me punch this in. Okay, so once you punch it in, you get 65.8. Then that'll be my B1. B2 will be 180 minus 65.8, which will be, what is that? 180 minus 65.8, 114.2. So this is B2 and B1. So the question becomes to double check, right? A plus B1, is that less than 180? Let me phrase that a little better. Check if A plus B1 and A plus B2 are less than 180. Okay. So 43.1 plus 65.8 is in fact less than 180. 43.1 plus 114.2 is less than 180. So we have two triangles, right? Okay, so that's how you verify. Now, what I'm gonna have to do is this. So I don't get too messy here. B1, B2, C1, C2, B1, B2, Sorry, that should be a 1. 2, 2. These are fixed, so we're good. There we go. Okay. So if I'm B1, that's 65.8. If I'm B2 to be 114.2. The B1 and B2, the lowercase are not going to change. Those are also fixed. Okay, so all we have to do is find C1 and C2, and that's opposite side. Okay, and then we're done. Okay. So C1, let's start with that one. Well, we can find C1 and C2 by subtracting from 180. So C1 will equal 180 degrees minus A minus B1. So that will equal 71-ish. Let's double check everything. 43, wait, no, 180 minus 43.1 minus 65.8. Yeah, 71.1. So that's not too bad. So we got those two answers there. That answer, now C2 will equal 180 minus A minus B2. Okay, so B2 is going to be 114.2. So this would be 22.7 degrees. Okay. So all we need is a C1 and C2. The rest we don't have to really calculate at this point. So we'll start here. C1 over sine C1 is equal to A over sine A. So that means that C1 is equal to A sine C1 over sine A. Plug that in, that will be 186.2 sine C1 is 71.1 over sine of 43.1. So that will be $257.8. That's C1. Okay. Same thing for C2. Solve for C2. That'll be A times sine of C2 over sine A, which is 186.2 sine of 22.7 over sine of 43.1. That will be 105.2. So those are that last side right here. Okay. So we found B1, C1, C1, B2, C2, C2. The rest was fixed. Okay, so that's number 3. I think that was the hardest question on this test. The rest aren't too bad. All right, number 4. Angle B and C are not given. Side A is not given. Since we don't have an angle and its opposite side anywhere, we have to do log cosine. Since we're doing log cosine, we don't have to worry about 2 triangles. So if you explain that part, you should be good. Yeah, let's use our log cosine's formula. All right, so little a is equal to the square root of b squared plus c squared minus 2bc cosine a. So just plug it all in, you'll have side a. The square root of 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times cosine of 46.5. So just plug that in, and you should get side A to be 13.192. We'll round to 1 decimal place. There we go. Now use the formula for angle B. Once you have all the sides, you can use the formulas for the angles, log cosine formulas. And they give you a list of them already solved for you, so you don't have to do too much. So a squared plus, so b is equal to cosine inverse of a squared plus c squared minus b squared over 2ac. So that'll be cosine inverse of 13.2 plus 10.5. Wait, dang it. 1 second. Okay, so just plug in the A, B, and C's everywhere. And that would be approximately on your calculator. Let's see. About approximate symbol. 35.3 degrees. So once you have A and B, you can find C no problem, right? So C will equal 180 minus A minus C. So that will be 180 minus 46.5 minus 35.3. So capital C will be 98.2, I believe. Yeah. And that's it. Got all the pieces. So we found B, C, and lowercase a. There we go. We got everything. Box that guy. Okay, so yeah. Number 5 asks for the area of problem 4. So use Hero's formula again. So S is equal to 1/2 A plus B plus C. Plug all those sides up here. A, B, C into here. And into here, and you'll save some time here. The answer is 65.5 squared units. Okay, so that's all the triangle questions. So let's move on to vectors. Number 6. Number 6, let me see, I already forgot what the question was. Okay, so A was go from rectangular to polar, so that means this is already X and Y. Polar to rectangular, meaning we're starting with R and theta. So for part A, X is 1, Y is 1. Okay, that means that R is equal to X squared plus Y squared square rooted. So that will be the square root of 2. All right. Now we need to know the angle. Well, theta is equal to tangent inverse of y over x, which is tangent inverse of 1 in this case, which is 45 degrees. So the point 1 comma 1 is going to go to square root 2 comma 45, or pi over 2. It would also accept or negative root 2 comma 5 pi over 4. So this is just a formula. Plug in 1, you get this. Plug this into your calculator, you'll get 45. So you got theta, you got r. So we're trying to change this into r theta. Okay, so now we got going the other direction. B. We have r equal to 5 and pi and theta equal to pi. So we know the formula says that x is equal to r cosine and y is equal to r sine. So x would be 5 cosine pi, which is negative 5. Y would be 5 sine pi, which is 5 times 0, right? Let me show that extra step here. 5 times negative 1. So this would be negative 5. This will be 0. So the point 5 comma pi will become negative 5 comma 0. Okay, so that's number 6. Number 7. Convert. We'll look at the question. They convert this into polar. So as long as you remember that x is equal to r cosine, y is equal to r sine, and it shouldn't be too bad. It should be theta. So plug in the x right here, cosine theta. I'm plugging that in right there. Plug that in right here and right there. So at this point, just multiply it out, right? This would be 4r squared cosine squared plus 4r squared sine squared equal to 3r sine theta. So factor 4r squared cosine squared theta plus sine squared theta is equal to 3r sine theta. So this right here you should see as 1 because of the Pythagorean. So you end up with 4r squared 1. So if you get to this point, you're pretty much good. You can solve for r if you want to. Divide by 4, divide by r, right here. To end up with r equal to 3 sine theta over 4. I think that's as far as you can really get. If you got that far, you're good. Okay. Number 8. Now we'll do it on the next page. Okay, number 8 says given the following, the initial point and final point, 2, 2, and 4, 5, find position vector. Okay. And then after that, we'll use that to find the magnitude. So all you got to do is subtract the final minus the initial to find the vector v. We'll call it v. So v will equal 5 minus 2, 4 minus 2. So that'll be 3, 2. Vector 3, 2. But that kind of weird. V is the magnitude of the vector you just found. So find the magnitude of v is what it said. So this will be the square root of 3 squared plus 2 squared. So that'll be 9 plus 4, which is square root 13. That's it. This magnitude and the position vector. Number 9 says find the unit vector. Then go through the points. To 2, and 4, 5. So that's basically the unit vector of the one we already found. So vector u will equal v divided by its magnitude, which we already have it. So you take the 3, 2 and divide by square root 13. So this will be 3 over square root 13, comma 2 over square root 13. That's it. Number 10, given vector u equal to I plus 5j and v equal to negative 2i minus 3j, find u dot v times 3u minus 2v. Okay, so this would be a constant right here, the dot product. I would just say do that first. U dot v would equal to the coefficient, the 1 times the negative 2 of the i's plus 5 times negative 3. So this would be negative 2 minus 15, which is negative 17. So there's a dot product. So this is really just guess I might need more space here. Negative 17 times 3 times u, which is right there. I'm trying to see how to write this prettier. I plus 5j minus 2 times v, which is negative 2i minus 3j. There we go. So multiply the negative 2, gave me these two. Multiply the 3, gave me these. Add them up. So that'll be 7i plus 21j. Multiply the negative 17, and you should get negative 119 I. Running out of space here. Minus 357j. So that'd be part A. The angle between part B, theta will just be equal to tangent inverse of y over x. No, actually, that's not true. Well, they do the next page. So that's the u dot v part times this. So part B. Part B is find the angle between u equal to, where is it? Let me just write it in this form. 1, 5, and v equal to -2, -3. Sorry, spaced out for a second. Let me find the formula. Shoot. Okay, so this is the formula for the angle. So u dot v over the magnitude of u times the magnitude of v. We did the u dot v on the last page, so there it is. We need the magnitudes though, so this will be square root of 1 squared plus 5 squared, so that'll be 26. Magnitude of v is 4 plus 9, so that's 13. The square root of 26 times square root of 13. Put that into your calculator and you should get 157.62 degrees. So that'll be your angle between vector u and vector v. And that's it.